Hello students. In this video we're going to develop the parameterizations around the circle, and I'm going to do it in two parts, counterclockwise and clockwise. So first up, let's do a counterclockwise parameterization. And what you see here is x is defined by cosine of theta and y is defined by sine of theta. Now what I'm assuming here in all cases is that r is going to be equal to 1, so we don't have to think about the radius. So this will just be all unit circles in the assumption. All right, so you've seen this kind of parameterization before in even Calculus 1 and Calculus 2, but we've seen this before in multivariable calculus, where you think of this in terms of like polar coordinates, right? X was cosine theta, y was sine theta. Anyhow, that defines the points x and y. So notice that if t is 0, then you start here at this point, and this is where x is 1 and sine is 0, and then notice that if t works its way up to 2 pi here, so for example when t is pi over 2, then cosine of pi over 2 is 0, sine of pi over 2 is 1, and you've worked your way over here to this point. So right now I'm just kind of doing this by points, and if we pick these 2 points, you can see that we're working our way around the circle in this direction. And then once you get to 2 pi, you would stop at the beginning again. Similarly, if you wanted to do a semicircle, if you start at 0 and then work your way around to pi, just as we did in the first example, we're stopping once we get to pi. And then similarly, if you start at pi over 2, then cosine of pi over 2 is 0, but the sine of pi over 2 is 1, so you start at this point, and then you continue all the way down till you get to 3 over 2 pi. So that gives you that arc of the circle. And then similarly, if you want to just get quarter arc of a circle, you started when t is 0, and then you work your way up to t is pi over 2, and you're going in a clockwise direction. Now, if you want to go in a in a counterclockwise direction. Now, if you want to go in a clockwise direction, the x will stay the same. Notice that x is cosine theta, and as t varies from 0 to 2 pi, the x direction is still going this way, even in the counterclockwise direction. And it would still be going that way even if we were to go around the circle in a clockwise direction. The x would still be going to the left. The coordinate that changes sign is the sign SIGN is the y coordinate, which is negative sign. So notice that if t is 0, once again we start here at the point 1, 0. But now if t is, for example, pi over 2, then cosine of pi over 2 is 0, sine of pi over 2 is 1, but we have a negative sign in front of it, so that shifts us down here. And so now we're going in a clockwise direction. And then similarly, when t is 0, cosine is 1, and sine is 0. But when t is pi over 2, cosine is 0 and sine is minus 0. Oh, so now we see this isn't going to quite work, and we would be down here if we're going in the clockwise direction. So these values for t will no longer hold, and we have to come up with a different set of values, okay? So we want to go in a clockwise direction, so what we're going to have to do, if I just get rid of that point there, is we need to start here at this point. And so what we probably want to do here is we want to start at minus pi. So if we start at minus pi, the cosine of minus pi is still going to be 1, and the sine of minus pi is 0. And then if we go up to minus pi over 2, then cosine is still going to be 0. And minus pi over 2, sine of minus pi over 2 is going to be minus 1. But we have this minus sign once again in front of the sine, so that's going to be a positive 1. And that sends us up to this point here. So we see that that parameterization is going to work. All right, let's see what happens when, in this next one, if we want this arc of the circle. So we want to move in a clockwise direction. So if we set t as pi over 2, then cosine is going to be 0. And the sine of pi over 2 is going to be minus 1, so that seems to be working. Now let's work our way up quarter of the way, and that would get us to pi, and then the cosine of pi is minus 1 and the sine of pi is 0, so this seems to be working. And then similarly, if we have 3 pi over 2, then the cosine of 3 pi over 2 is 0. The sine of 3 pi over 2 is minus 1. Minus 1 gives us a 1. And this all seems to work out. And then finally, let's see if this one's going to work. The cosine, let's see, we want to start here. So the cosine of 0, oops, that's not going to work. So we can't go with this one. So if we want to start there, we're going to need to start at pi over 2. Because the cosine of pi over 2 is 0, and the sine of pi over 2 is 1, but that would be minus 1, so that puts us down here. So if we make that minus sign, that'll work, because then sine of minus pi over 2 is minus 1, and minus 1 gives us a 1. All right, and then we could work our way up to, from minus pi over 2, we want to get down here to 1, 0, so we work our way to 0, and then the cosine of 0 is 1, the sine of 0 is 0, and we've now just done a clockwise parameterization. So you have to be careful with a couple of these parameterizations, and the tricky part is going to be in choosing the values for t. All right, good luck.